They'll do what you asked them to do, or they will contact you so that they help it put it together. So how would you get, to make it useful, how would you get this then to a stage where you have all the right components in place and then it's actually working?
I can show it, Stephen. So let's go to the next slide.
Let's switch. Yes.
Exactly. So the question is, that is the goal. So we want to have a fuel cell system with a balance of plant, including the balance of plant. And the question is how to design it. And we do not take a catalog and look, okay, here's a pump and there's a blower and so on. We do it with a simulation model.
Yeah.
So, and the first question is, what is the requirement and the demand? So what is the power demand that should be produced by the whole system?
Yeah.
Exactly. So in a vehicle application, that could be a load profile. So that means we use the load profile in a simulation environment. We can show it here, or I can show it here. So in the background, there's this graphic about this load profile.
Can we just zoom that in or try that? Yeah. So,
Exactly.
Okay. So what the load profile means, how much energy is required at what time?
Exactly.
Okay.
So how much power or energy is required at what time and so on, and this in a special period.
Yes.
Exactly. So we use this and go with it into a simulation environment. So this is a basic model. At first, this is a basic model. So that means there are all components in the balance of plant that are necessary to run the fuel cell stack. So, but these are kind of generic components. So then with the load profile and with the input into the simulation model, we get a kind of requirement sheet. So that means there's the information, what compressor do we need, what is the mass flow, and so on.
Yes.
So several parameters for designing the fuel cell system.
Okay. So this is a mathematical simulation.
Exactly.
Kind of it is, huh?
Exactly.
Okay. Where you can run or simulate different parts of that system which we just saw before.
Exactly.
Okay.
Exactly.
And then,
but that is not the final status of it. So the next level is we have the requirements on the first side, but now the goal is to find suitable components. So, in example, when we're talking about a compressor, you will not exactly find the compressor that fits exactly to the specification there. So that means you go in contact with different suppliers, compressor suppliers, and they send you normally the performance maps. We insert the performance maps into the simulation model, and in the end we get a very precise simulation model, so the next iteration. It's called the iteration, and this is a kind of digital twin. Let's call it like this.
So speaking of digital and choosing between, just to mention, you may not know this, but this is exactly where, let me say, HiFinder is trying to add value, that when the engineers are now selecting different components, they can actually find different options on HiFinder. And and then when they find one, then they'll do what you asked them to do, or they'll contact you so that they help it put it together. But please go on. Yes.
Exactly. So that means just the steps back. So first there was the requirement, then there was the basic simulation.
Yes.
Then we modified the simulation model to this digital twin. Now we can create different concepts to go into different to make the system very efficient, in example, to find components that are very efficient. Or we can take decisions about do we want to run it in a static operation mode or operating mode or more dynamically and so on. So these are different concepts, and we have the KPIs on hand to decide it.
Yeah, okay, understood.
Exactly. So and when we go to the next slide, so this is the process again here, just very easy. So we start with a simulation, with a basic simulation. We we insert the system requirements like load profiles and so on. We start with the first sizing of the simulation model, then we select a concept, and there are several iterations to design the system.
Okay, wow.